good afternoon. Now today I will discuss about the pattern allowances of the casting process, and at the end of this lecture student will be able to learn the all pattern allowances and their construction. Different pattern allowances has been created to the casting process. Why we give the pattern allowances in the casting process? What are the causes for providing the pattern allowances? First, sometimes patterns are not exactly the same size of the desired casting process. That's why we, to compensate the patterning process, a removal of the pattern and dimensional and structural changes during the casting, we are provided the pattern allowances. Mainly to compensate the patterning process, removal of the pattern from the mold cavity and dimensional and structural changes during the casting. That's why we provide the pattern allowances to the casting process. And also different pattern allowances are there. What are the different types of pattern allowances? First is shrinkage allowances, second is draft allowances, third is machining or finishing allowances, fourth is sack allowances, and fifth is distortion allowances. That 5 allowances are the most important allowances in the casting process. Now we are coming to shrinkage allowances to the casting process. First we discussed about the shrinkage casting of the pattern process. So when we provide the molten metal to the mold cavity, after solidification the molten metal will be shrinkage. So here we are seeing in that particular picture, when we fill up the molten metal up to that portion, okay, fully we fill up to that portion, but after solidification what happens? Now the molten metal will be solidified, and due to solidification of the molten part, that allowances will be created. That allowances will be created. Means if we consider up to that is the datum surface, if we consider that is the datum surface, means if we are taken the molten metal up to that surface, after solidification the surface will come to that particular position, means the reduction height due to solidification shrinkage, means that is the shrinkage of the molten metal. Means here reduction in height due to solidification shrinkage, means that is the reduction will happens to that solid shrinkage. Okay, means then that is the shrinkage cavity. Okay, that is the shrinkage cavity, and it is also molten metal, because we know the heat extraction takes place started from the mold surface. Means that zone first take the solidification, then it will come towards the center. Okay, means that is the solid metal, means it will take the shape after solidification. Okay, then here sometimes solid thermal contraction also happens. Means if we sometimes after solidification that type of shrinkage will be happen in that surface also, and in that type of shrinkage will be happen in that surface also, upper surface also. Sometimes that type of shrinkage cavity also formed. Means in that position the molten metal does not fill up properly. Okay, that is the some solid shrinkage in the casting process. Now what happens now when liquid metal pour into the cavity, the mold together cooling and solidify takes place. So in this process phase will be changes. Means due to heat extraction the liquid molten metal converted into solidified product. Okay, that is known as shrinkage. Means volume of the liquid metal is higher than solidified product. Okay, so due to that solidification, the shrinkage will take place to that particular casting process. And also patterns made slightly to compensate that shape of the particular casting product. So here, as per our requirement, the pattern may be slight more than the required size, because due to shrinkage, the solidified product volume will be decreased. So due to that things, if we are taking the bigger shape of the pattern, then bigger cavity will be formed. So after solidification, the actual product will be produced with accurate dimensions. So that is the main issue. Patterns may be slight more than the required shape. Another, the exact value depends upon the alloy of the cast as follows. Means what are the different metals has different shrinkage allowances. So we see in that particular table, so typical pattern makes shrinkage allowances of different metals and different shrinkage allowances. Means volume percentage shrinkage, volume percentage is there. In case of number one, metal alloy, aluminium. So in that case, solidification shrinkage volume percentage 7.1, and in case of cooling shrinkage volume percentage 5.1. Okay, that maintains solidus temperature in degree centigrade 660 degree centigrade. So in case of copper, we have seen that solidification shrinkage volume percentage is 5.1, and in case of cooling shrinkage volume percentage is 6.4. So temperature maintained, solidus temperature maintained 1083 degree centigrade. In case of ferrous, pure ferrous metal, so in that cases we have seen that solidification shrinkage percentage volume, that is 3.5, and cooling shrinkage volume percentage is 6.0 to 7.5. Maintain the temperature 1535 degree centigrade. In case of steel, we have seen that 2.5 to 3.0 shrinkage, solidification shrinkage volume percentage. Okay, and in case of cooled shrinkage, the all are volume percentage, that will maintain the 4.2 to 6.0, and in case of temperature maintain 1500 degree centigrade. In case of ductile cast iron, it is maintained minus 4.5 to 2.7 percentage solidification shrinkage, and in case of cooling shrinkage, that maintain 3.0 and maintain temperature 1148 degree centigrade. In case of grey cast iron, 2% of carbon present and maintain 1.05 percentage. In case of solidification shrinkage, and cooling shrinkage maintain 1.0 and temperature maintain solidus temperature 1155 degree centigrade. In case of zinc, the 4.7 solidification shrinkage, cooling shrinkage is percentage 4.0 and temperature maintain 420 degree centigrade. That are the some examples of the typical pattern makes shrinkage of various metals. Means what will be the solidification shrinkage, what will be the cooling shrinkage, what are the maintained solidified temperature, what are the required temperature. So that are maintained in case of different metals and different solidification shrinkage and cooling shrinkage, and also maintain different solidification temperature. Shrinkage allowances, in case of solid shrinkage, already we have seen that what happens. Now here, when we pour the molten metal, the heat extraction takes place from that particular surface, and due to higher heat extraction from that particular surface, the solidification started from that particular mold surface and it goes towards center. Okay, so here if it is, we consider that is the datum line. So when we pouring the molten metal, the molten metal takes place up to that datum line. Okay, after solidification, then it will come towards that particular positions. Means that is the shrinkage. That is the solid shrinkage of the molten metal. Sometimes that type of cavity also created. Means due to solidification of the molten metal, sometimes that type of solid cavity will be formed to that particular molten metal also, and due to after solidification, that type of shape also generated. That type of shape means here gap will be created. Here gap will be created. Means that is the shrinkage to that particular molten metal after solidification. That is the solid shrinkage. Now, shrinkage allowances in case of liquid shrinkage, what happens? Now, if we consider that is the molding box, okay, or mold cavity, we have considered that is the mold cavity, okay. So, we here pouring the molten metal. After pouring the molten metal, it will take that particular shape. It will take particular shape, okay. Then the heat will be extracted from the mold surface, and due to heat extraction, the solidification started from that particular surface, mold surface. Then it will go towards the center. It will go towards the center. Okay, then after solidification, that type of shape takes place. Means that is the shrinkage, means allowances will be created to that particular cavity. Okay, that is, and also reduction level, height reduction level means if we consider that is the datum level, so in that datum level, after solidification, that gap will be created. That is also height difference. Reduction level due to liquid contraction. After liquid contraction, that gap will be also created. Okay, and also that type of gap also created to that particular surface, means that is the solid structure already formed to that particular casting product, and that gap will be created. Okay, that is the liquid shrinkage. Now we are coming to draft allowances. What is draft allowances? Draft allowances. Draft allowances means here what happens? Now we take the pattern and we provide some angle or taper shape. Means we see if we are taking straight line, we are taking straight line to that particular pattern, we are taking straight line, means no taper will be provided, and it will be placed to the particular molding box. Then we give the molding sand material and some additives will be mixed. So when formation of the mold cavity, then we want to remove that particular pattern. So due to some corners, some mold cavity shape may be affected. Mold cavity shape may be affected due to sharp corners. If we provide that type of taper, or we provide some angle to that particular portion, maybe it will not affected that particular portion. And also mold cavity shape also does not change. So due to and also during removal time of that particular pattern, the mold cavity does not affect it. So for easy removal of the pattern from the mold cavity, that's why we provided the draft to that particular pattern. And what is the leading edge may be break off or get damaged during the pattern is removed from the mold. Means when we remove the pattern from the mold cavity, the leading edge may be affected, means leading edge may be eroded, and due to erosion of the leading edge, that quality after solidification, the quality of the product will be deteriorated. So if we provide the draft or taper or angle, so the quality of the product will be better. And also we easily remove the pattern from the mold cavity. So outer surface means mold cavity inner surface does not affected by that particular pattern when it will remove from the cavity. Finishing and machining allowances. What is that? Means sometimes after casting process, means after solidification of the poured molten metal, then finally we have got the cast product. And after getting the cast product, sometimes the cast product outer surface finish is not good. Means it will keep some impurities and some extra shape will be, some bars will be formed, some depression will be formed. So we require final shape. Means final and finished product we have required. And sometimes we extra dimension we have generated to that particular casting product. So as per required dimension it is needed. So that's why we do some machining allowances. What are the machines we have used? Turning or grinding process, some other finishing process also we have used for providing for better surface finishing to that particular cast product. And also by finishing process also we have got the better surface quality and also get the better quality as per our required dimensions. So that's why we provide the machining or finishing allowances to that particular casting product. So the amount of allowances adjusted to the particular pattern based on what are the things are required. Type of machining process means if we generate the extra dimension to that particular casting product, so means what type of machining process we have used for finishing purpose. Another material use, which type of material we have used for producing the cast product also. Another requirement of the accuracy means what type of accuracy means precision accuracy is there or rough accuracy is there. So depends upon that things also. Another last is molding method. Various types of molding methods are there, casting process are there. So due to that thing we have provided amount of allowances to that particular pattern. Generally it is ranges from 2 mm to 15 mm. That depends upon the size and material of the part. That is vary from 2 mm to 15 mm based on size of the material of the part. Okay. Now shaking or wrapping allowances. So in that cases when we want to remove the pattern from the mold cavity, so sometimes we shake the molding box. Some we shake very carefully, we shake because some extra shape will be generated. Extra shape will be generated to that particular mold cavity, and so due to generation of extra shape of the mold cavity, we easily remove the pattern. Means other surface means inner surface of the mold cavity does not affect it. That is called shake or wrapping allowances. So what is that? Means the pattern are removed from the mold cavity. Sometimes the pattern are wrapped easily. Wrapped means it will be shaked and easily removed from the cavity. Means due to shaking or wrapping, the extra shape will be generated to the mold cavity. And due to extra shape, easily we remove the pattern from that particular mold cavity. So sometimes to compensate for enlargement, the pattern dimension to be reduced means, so extra shape will be generated. So we pour the molten metal and as per mold cavity shape, the product will be generated. So to compensate the for enlargement, we keep the pattern dimension less. Keep the pattern dimension less. If keep the pattern dimension less, so it will take the particular shape of the cavity. After shaking or wrapping, it will take extra shape. So the ultimately finally we get the particular final finished product. Means if the dimension of the pattern is less, so product after shaking the cavity shape will be formed. So ultimately after final casting process, finally we have got the particular accurate shape of the casting product. So it is called shake or wrapping allowances. Then distortion and camber allowances. So in that process we have seen that when we mold cavity cooling process, the stress is developed if metal thickness is different. Yeah, this thickness also different, this thickness also different, and also due to uneven metal thickness or removal of the heat from that particular cavity is different. If removal of the heat is different and thickness also varies to that particular section, so stress will be generated in different portion. Where stress will be generated to that particular portion, so in that particular surface the curve shape will be, that type of curve shape will be generated. That type of curve shape will be generated. Okay, so means due to uneven metal thickness and more cooling to allow in the casting, that stress may be included distortion and bending in that particular portion. Means due to non-uniform heat removal from the particular section and due to uneven metal thickness, the stress will be generated in different portions, and due to that thing the stress will be generated to that particular portion. particular component or part, and in that particular portion bending takes place. So how to avoid that thing? How you avoided distorting the pattern in opposite direction? If we consider it will bend it in that particular side. So here in that cases we use the process. So in that particular section heat removal will be take in opposite directions, and also metal thickness also we vary in that particular cases. Means we want to the bending in that side. If we do not want the bending, do not want any bending shape, so we provide the particular cooling process to that particular portion. So heat removal from that every section will be equal, and also the thickness also maintained same. So in that cases the metal will not bend it. Okay, and another thing, the casting part thickness also uneven, so solidification process is not uniform. Thermal stress provided to that particular section, means due to different heat removal to the particular section, so that will thermal stress will be created, and due to thermal stress the bending shape will be generated. So we avoided that thing by using that thing in opposite directions. So to avoid sometimes we avoiding that bending shape, sometimes we use some camber. We use some camber for providing the particular straight shape to that particular product. Okay, so to avoid camber provided in the opposite direction, if we consider that it will be bended in that direction, so in that particular direction we provide the camber, and due to providing the camber it will not bend it in that particular side. So in that way we avoided the distortion allowances. And end of this lecture we conclude that students have learned so different pattern allowances and how they constructed the pattern allowances. That is the main thing of this lecture. Now I will see the video about the different pattern allowances. What are the pattern allowances? And pattern is the replica, the model of the particular casting process. Sometimes we take the slightly larger than the pattern shape.
When the cast solidified, it shrink at some extent due to metal shrinkage property during cooling, so a pattern may slightly larger to compensate.
Particular cast object.
There are other reasons which are due to poor surface finish and casting limitations.
What happens sometimes after casting, the poor surface finish will be, after solidification of that to the particular process, some extra space will be generated, that is called allowances. Now first we are coming to shrinkage allowances. So in that cases we have seen that, already have seen that after, as per mold cavity we take the molten metal, and after solidification that type of gap will be generated to that particular casting product, and that is called allowances. That is the gating system, and that riser will be used as a reservoir to providing the extra metal. Pattern we take the particular more desired shape because to compensate the exact dimension of the casting product. Draft allowances, if we are not taking draft, so that type of crack will be generated. If we are taking that angle, so no, that type of crack will be generated, and easily we remove the pattern. That is the draft allowances. That is the distorted casting, and that is the taper casting. Means here no extra crack will be generated. That is the machining allowances. That is the casting product, means surface is rough surface generated, but we have required the finished surface. Means after machining, that type of finished surface will be generated to that particular using machining allowances. Better surface finish we have got, and accurate dimension also we have got in that particular process. distortion allowances means due to that thing, due to uneven metal thickness, due to non-uniform cooling, the thermal distortion, thermal stress will be generated, and due to thermal stress, that type of shape, bending shape will be generated to that particular pattern. So if we use the camber type pattern, so the thickness will be far better. And also we use wrapping allowances, and due to wrapping allowances, the extra cavity will be generated to that particular process, and also the shape will be generated, and easily we remove the pattern. So that are the 5 allowances: shrinkage allowances, draft allowances, machining, distortion, and wrapping allowances.